get this round and measure it and see where we need to be. Well, we're up to 77,082 miles. Doing good. Little brake squeal is the only concern I have. We're at Dawn's. Time to get out and see what's going on. There's the cow sitting out there, not a care in the world. And there's the horse. These two are the only two livestock Don keeps. He's a big rancher. And they're going to kind of like a retirement home. All they do is hang around and keep the pastures mowed. They notice that it's springtime and all the bluebonnets are out in force. This is just a little patch. You should see some of the fields around here, but can't let the old Rock 2, which is doing pretty good, get on the grass. What else can we see around here? Ooh, look, building. There's a building in progress. And look who's up there on the roof. I can't hear you.
I'm trying to motivate myself to put this last rafter up.
I will translate for the people. You're trying to motivate yourself to put the last rafter up. What if I were to get a gun and start shooting at you? Would that help?
No, I'd probably duck and get down.
You like my new little play toy?
Doesn't even look like a camera.
It's my spy camera, 007.
Looks like the camera fell off. Looks like you had a camera there, and now you don't have a camera there.
I got a big camera here. This is actually a 4K.
Just doing this stuff.
Yeah.
High tech. High tech. Stability.
Well, it keeps it stable so we don't make the viewers sick. What are you doing here?
Putting roof rafter number 18 up.
And you've put every one of these boards up by yourself.
Well, nobody else around here to help, so
Well, if you hadn't pissed off everybody, they'd come help you.
You gotta do what you gotta do.
Well, you're going to be pretty much ready to put the roof on soon.
I want to keep the siding first for stability. If I put the roof on without the siding, it'd be like a big sail that'd just fly away.
I'm going to walk around.
Walk around.
A chicken in the background. Now last year, Don added on this section with the door and the little carport here all by himself. And when he built it, I told him, I said, it's too small. He claims he was out of money or something like that. So now he's adding on to it. What?
OSB was $70 a sheet back then.
Are you contradicting me?
Yes, I am.
Why don't I get closer where the people can hear your lies?
Confirming it.
Confirming what?
The roof wood was out of sight. It was $70 a sheet for the crappy OSB stuff.
Well,
$9.95 a sheet. That's why I'm building again.
okay.
Big difference.
You just come up with anything to try to tell me I'm not right. So then I came over, put a link to that video, and he was at it again. He put this little room right here. This was all he was going to enclose. And he stopped the concrete right there. So finally, common sense prevailed, and he's moved the concrete all the way out to the end. And now he's going to put walls up.
Close it all in.
Close it all in. I think it'll look nice.
I
Give
like
him some
carport
space.
'cause I like to work outside, but I'd rather have the space.
Well, I think you could.
Space is better. Especially at the cost of wood right now. It'd be kind of stupid not to have close it in.
That's what I said last year.
And the cost of wood was way too high.
Well,
Just what the OSB cost me for that addition, I framed this whole thing and got the OSB and the sheathing. So there you go, that's a big difference.
boy, it's windy out here.
Always.
If you'd get this building finished, I wouldn't be in the wind or the sun.
Were you pretending like you're hurt with the wrist thing on? Were you trying to get sympathy from the viewers?
Yeah, that's what I'm doing. Quit giving away my sympathy getting tips.
So you gonna do my nut today?
I'm going to work on your nut today.
Hallelujah. Praise the Lord.
It'd be better to just praise Steve.
I haven't seen it done yet. Maybe I'll praise you when it's done.
All right, time to go inside.
Bye, peeps.
Did you know you have some serious safety issues here?
Of course I do.
There's nails sticking up.
And I'm working with
And-
Crocs. Make sure you tell everybody I got Crocs on up here on the scaffold. Right? You get some good comments there.
You want to piss somebody off, huh? Are you
Yeah,
working with Crocs?
I'm on Crocs on the scaffold and ladders and rafters.
Where's your PPE? Hi, baby. Did you miss me? This is an Axelson 16, one of the newer models. I forgot what year it was made. It's one that's got the faster speeds. This is no going up to 1127. I tell you, you get a 16, 18-inch chuck at that speed, it's plenty. This one I sold to Don about 3-4 years ago. We drug it over here and Don stripped it down and refinished it and redid all the plates, made it look fancy. And I get to come use it once in a while. I've got another 16 sitting in my shop that I'm still on the fence about selling or not. This one's only it's an exact model of this one. In fact, I don't think it's very many, maybe like 2 serial numbers away. And that's weird. But this is the way we left it last week when we figured out that this thread is a double start thread. You can see on one side, that's where it starts. But then if you go to this side, you see it over there, that's another start. If you put a gauge on this, this is a 4 thread per inch Acme screw. But in reality, it's a 2 thread per inch Acme screw with 2 starts. And what that means is that this thread here starts and goes around and comes back up over here. And then here. So in 1 inch, it makes 2 revolutions. Well, a thread that's only making 2 revolutions in 1 inch is not very stable. So someone got the bright idea of coming up with putting another thread in the middle. So this is in effect a 2 thread per inch with one starting here and one starting here. Where you say, how are you going to do that? I'm going to show you. Our problem is this is a nut that I have to make for Don's wannabe planer, and Don has got 4 threads per inch measured on this other shaft, and that's what he thought it was. He had never ever heard of a 2-start thread, and I didn't even occur to me to tell him to look until after I made this nice nut, threaded it up, and it wouldn't start. That's why we have this rigmarole set up here, so that we can test the nut on this as we're making it, which was working out fine, except that's when we found that it was a 2-start thread. So today I'm going to put the tailstock back on the Axelson, get everything set up, and cut a sleeve for it. I've got a different way to do it today. This is Don's wannabe shaper or planer. It's a little baby shaper. Isn't it cute? It's still useful for some things, but you know, the reason you don't see many of these is that mill over there can do so much more in the same footprint as this one. A lot more, in fact. That's why they don't make these in the United States or very many places in the world. I think somebody does, but Don has taken this one and show you a picture of what it used to look like. And turned it into this. That motor had to be taken off and sent to a motor shop and redipped because the insulation was bad in it. They put new bearings in it, redipped it, ohmed out great. Don's got all the electrical work done, got all the handles polished up, everything is painted, and it's laying here ready to be assembled. There is the screw that Don measured also, that we were using to test the nut fit. That's a single start thread, not a double. That's when we found out, after this one fit the nut very well, it didn't fit the other one. The nut we're talking about goes right in this little space right there. In fact, this assembly is the cross feed table screw, and it bolts onto the side over there and goes through that hole right here all the way to the other side. And this nut, let me get the nut. Bolts onto the table here and goes into this area and goes back and forth. For those of you that don't know, the nut that was in there was made out of cast iron and is just eaten all to pieces. Let's see if I can find it over here. I've worked with worse before.
Couldn't hold it straight.
I've worked with a lot worse. That wasn't in half, sir. How much did you?
Oh, you said cut the tip off, so I cut the
And
tip
then
off.
cut it in half.
Okay, cut it in half.
What we have here is a failure to communicate.
Properly provided.
It's that second half they always miss. They have to put you in the hot box.
Provide instructions.
Let's provide instructions. Failure to communicate. Anyway, what we're doing here is Don destroyed his nut somehow. Well, he didn't do it. It came that way. This is the horizontal feed nut for that. What year is that Cincinnati?
I can't remember. I knew it at one time. Seems like it's
Called old age, dementia.
I can't remember.
Anyway,
Let's just be guessing.
we need to make a left-hand Acme thread for that shaft. And we're not going to use this. We're going to use bronze for a good nut. Like I was saying last week when we were here, I made these on my CNC machine for test pieces. And then I brought some cast iron pieces off of the castings that we did over at Windy Hill Foundry. I thought, heck, man, those make nice test nuts. So I did it in this instead of this, and it fit on that other shaft so well, I said, we're going to skip this and go straight to this. That's a $200 piece of brass right there, or bronze, bearing bronze, 6200 or something. It's specially formulated for nuts. And I went ahead and finished that one off, and that's when we found that Don had made a mistake. That's my story. So, what do we do about it? Don told me, go ahead and cut the nut. If you mess up, we mess up. I'm not going to hold it against you. Don't worry about it. Well, we did, and we didn't mess up the nut. We messed up the threads identification. So now what do? Don ordered another nut piece, a piece of bronze. It's a 3-inch round, 3.5 inches tall, and it was shipped in for right at $190, $200. But I got to looking at it, and I went to work on my CNC, and then the stupid thing wouldn't go into second gear, so it started me thinking of another way of doing this. And I got to thinking about sleeving this piece here. Now, the threads on this is the diameter. On the original cast iron one, it wasn't big enough to sleeve. But I'm looking at this, and I've got a lot of space. I made this one a little thicker and taller, so I think I can sleeve this one. So I'm going to bore this one out, put a piece of bronze sleeve inside, then thread that bronze. And I've got lots of space. I can take and run nuts in here to the side and stop it from moving, Loctite it in, and I don't think it'll ever go anywhere. We also came up with another idea on keeping this nut oiled. Now, what happens on this machine is oil drips off of the table out of here, comes onto this rail, and then drips down in here. And there's a well on the original nut that would take this oil and feed it into the nut housing. Well, obviously it didn't work very well. And once you put the table on here, there's no way to get to that nut. So what we decided to do is come up with an oiling system, and I don't know if we're going to put it here or on the other side, but we're going to take and drill a hole in about this location either side and put a tube that comes in, and then put a fill pot out here on the edge. And to oil the nut positively, we're going to move the table over to a certain position where that oil out of that tube will drip into that cavity on the nut. It'll still get oil from up here, but then we can make sure it's getting oil by dripping a lot more into that positive feed system. So that's what we're going to do. I'd show you my new camera that I bought. This is a DJI camera. It's got its own gimbal built into it. So as I turn it, it follows and points. I have a big standalone gimbal for that camera, but it's bulky and hard to do. This one's got a 4K video. The picture seems to be pretty nice. Tell me what you think about it. It'll take me forever to pay for this one with YouTube video. Couldn't help myself. It was only $500. And it was my birthday, so. Anyway. Put it to sleep. Handy. Now I've got my piece of bronze stock. This is my backup piece. This one piece here was $119. And I think it'll make it. The backup plan is to use the piece of bronze that Don bought. We'll see. First off, I need to put this in the lathe and bore it so I can see what size I'm going to have to go and how much will be left here and how big of a sleeve I can get into that hole and still feel safe that it'll stay there. The reason I didn't do this on the original nut was this area was much thinner on the original nut. Like almost non-existent if I had put a sleeve in it. And there wasn't any good way, and plus cast iron is brittle. This bronze is not as brittle. And I'm confident there's enough area there that I can get a sleeve into. I'm gonna try it at least. Either that or I gotta go fix the CNC. Scrap aluminum for a test nut, and we'll go from there. Now for this operation, I need to put the tailstock back on. And take this off, but luckily this is just set up on a hoist. We'll move it over here and sit it on the ground. This little jib hoist Don and I made in this video, there maybe up here, I forget. Probably one of the nicest, easiest, simplest designs I've ever found. You can't see what I'm doing. Actually, you can't even see the design. Look up there. The post on the wall there is a 3-inch Schedule 40 pipe. Got a small, looks like a 5-inch I-beam with a gusset. And the really nice thing about this, and I didn't invent it, I stole it. Maybe we could focus up here. Don went up into his attic and put a plate across all the rafters, and then where the round part of the pipe, the gray part meets the black part, I turned a piece of metal to fit inside the pipe. And it's greased up real well, and it's just got a little stub shaft coming down from the ceiling, and that keeps it in place up there. But the really interesting thing I thought of was down here on the floor, and he's got it covered up with all his crap. But all it is down there is a piece of angle iron bolted to the plate of the wall and into the concrete with a trailer hitch ball sticking up, a 2 5/16 ball. And I made a socket on the lathe to fit that curvature of that ball and the outside dimension of the pipe, and we put it up inside the pipe, and that's what it pivots on. I didn't come up with it, but it sure works nice. I know he spends 20 minutes every time I come over here, before I get here, hiding things. Can't even find paper towels. I'll use a blue rag. I'll show him.
You working in the Acme?
I've adjusted it to the proper temperature.
67, my God. I don't think it'll go that low.
I'm experimenting for you. The viewers would like to know if you spend 20 minutes hiding things from me before I get here. I can't find the paper towels even.
I don't think I have any.
You don't have paper towels.
Hey. Hey.
Did you buy any?
Hey.
You found paper towels. Did you buy any chip brushes?
No.
No.
You should have brought some. You know better.
Thank you, sir. Told you we hit them. You also notice he left when the work was about to start. All right, gotta lower the table now. Let's make sure it's. Nope. Now I know I'm going to need this because I got to take it off to do the boring stuff. Well, not the boring, but testing it. I'll just leave this set up over here. Gotta put this back in the forejaw. I gotta line that hole up to where it will work, so I don't screw it up. Now that I have this Now I can take and make it loose. It won't fall out. And that maybe make it self-register a little bit. Did self-register, but not on the flats that I made for it. Basically, I want this nut to be straight out and in line because I'm going to bore it again. Now I'm going to back this off a little bit. So I can watch it go around. How's that? Now what I'm watching to do here is this right here. I'm watching to see if it's touching that bore evenly or not. Frankly, I need more light. Can't get really close to it, but maybe you can see it on this. If you look at the very top, see how it is? Now it's getting to be open. See how much open that is? That's getting tight again. So that tells me this needs to come up just a fraction. So what I'm going to do is go to the other side and tighten it to push it over, because they're just loose right now. And then we'll see what happens. See how there's a big gap right there, up in there. I'm watching that gap down in there and seeing how close it is. I'm going to give it one more tightening on these two. Now, I'm happy with that. And if you I'm happy with that gap. I'm going to tighten this up some and see how it fits all the way around now. That's close. That's as close as I'm going to get it. All right. Now we can bore. Of course, if you look at it with it turning and spinning, you can see little imperfections a little bit. So let's do that. This is the world's best tailstock, bar none. I bet I've used 30 different kind of lathes, I love this one. This is your lock for the quill. You have two back here to lock it to the bed. Now on my 20-inch it has 4, but this one is 2. This is its easy mode of travel, back and forth. You can lift it up off like that. A lot of times these are missing when you find them. But the best thing about this is this hand wheel. You'll notice it's on this side, not down here on the end. I like that. And even better, you grab it and you pull it out, and now you have a 2-speed tailstock. You push it in, and it's fast. Pull it out, and it's slow for drilling. Makes your setup times a lot faster. Well, basically what I'm going to do is trim this down to where it fits in there. I've got quite a bit of whittling to do. But first I want to bore this out as big as I dare. You saw how I was using that live center to get in there and make it pretty much the same. Well, I then turned on the lathe and used the boring bar and adjusted it to where it's perfectly equal on both sides of this. Don't know if you can see in there, but that's what I've done. So now I'll be able to put another piece of this in there. But here's the problem. If you look around Don's shop, this is the only lathe he has. And I just spent an hour getting that dialed in perfectly. Went to eat lunch too, though. And now I don't want to mess with it. I want to leave it right there. I want to bore it. I want to put the sleeve in it and then bore it again for the threads. So what do? I think this piece of bronze is going to go home and meet Bob. I'm going to finish boring this out, take some really good measurements on it, then go home and use Bob to make the outer diameter. That way I don't have to mess with this. So let's get to it. All right. Now this dimension isn't critical because I'm going to bore it out as much as I can to get as big a piece of sleeve to go in there as I can. And so it's just basically going until I feel lucky. As you can see, moving that over got rid of all the threads evenly now. So now I'm pretty much dead certain that that's where it was before. And if I could get the most meat on these two sides left. Now we can just start boring again. Take out what we need, which is as much as I can get. Pretty nice finish. Well, as you can see, it's about as far as I want to go. Maybe even a little bit less. Let's go a little bit less. I think we'll have enough if I do that. All the way through, and stop it, change directions, come back without touching it. Just take some of the flex out of that bar. Okay, I'm going to stop it. I'll pull back 2/1000ths. 3/1000ths, change direction, go again. All right. Gear, reverse, back in gear. Well, we're back over at my shop, and we're going to get Bob to help us out some. You know, I have 5 lathes, so I can leave one set up to do things and go back and forth, and then specialty like Bob here makes it a lot easier on yourself when you're doing a project like this nut. I left the nut that I bored out over at Don's shop in the old Acme 16 there, and it's ready to keep continuing work. If I didn't have Bob or another lathe, I'd have to take that nut out and get another chuck on there and turn this piece of bronze down. Well, I've got Bob, so you can afford it. If you got the room, the more lathes the merrier. Now Bob is sitting here ready to start whittling on that piece of aluminum I've got chucked up. Instead of messing with this really expensive bronze, I'm going to make a substitute that I can go check that bore with. So I make sure I've got the right diameter to go in that bore without messing this up. Aluminum's cheap compared to this stuff. So I'm going to take and make a 3-inch piece. Before I left, I took some step gauges and went in and measured that piece, that bore really well. And I'll show you a picture of it. And it says that I need to make the new piece to fit that bore perfectly 1.716. So see how close I can come. I'm not going to make it 1.716 all the way. I'm going to make a couple steps on it to where I can use it as a go no-go gauge to see, because I want to leave some space for the Loctite to sit in. So I'll probably make 1 inch of one diameter, then go up and then go up, and so I can see what it is. I got a big piece of aluminum here, so I may even make it more. So the limitation on this is how far I can go over with this extension. I might have a longer one. I have to look. Yeah, I can go over about 1 inch farther. Well, we'll see how this goes. If I need to, I'll go over 1 inch farther. I was truly blessed when I found Bob. Came out of a machine shop that the man died from Alzheimer's, and seems a lot of people I've met that run machine shops have died from Alzheimer's. So maybe the chemicals we use, I don't know. Anyway, I'm going to take this down and we'll see what we can do, how close we can come. First thing I'm going to do is get rid of that edge and flatten it off. This is the joy of having a chucker. Your tooling, almost all the time for me, is all set up. I need to go a little bit faster. Now Bob, see up here, I've got speed controls, and I have a 1, 2, and 3 selector for speed. So this is on 1, and 1 right now is running about 400 RPMs. If I just simply change this, I'm now up to 1,050. If I change this, I'm up to about 1,900 and can adjust it up to 3,000 with this style here. But I'm going to take it down until I get it balanced better. This is electronically controlled over here, or electrically controlled, not electronic. Got a clutch here for it, and then I can change the feed over here. You might enjoy being on the other side. I don't know what I can show you here. Well, I could show you Bob's feed speed, carriage feed, and that controls both the in and left and right motion on this lathe bed. You change the speed and then you stop left and back and forward basically. Now Bob's what you call a chucker lathe. Bob's got an automatic threading attachment back here that I haven't finished hooking all up yet, but it can do attachment threading about this long. In fact, the way it does that is you use these items on the back side, and this is basically a template, and this is a 32 threads per inch. And you set it up and it will automatically make that thread by following this pattern. Someday I'll get to it, I'll show you how. But when you, it doesn't have this model doesn't have a feed screw on it. So that's the only threading it can do. But Bob can do this. Can hold 8 tools, lock it in place, back over here, bring it up to the work, touch off, and then I'll use this down here. Come on guys, keep up, keep up. Down here's the clutch for making it go left and right. And I can speed that up with this dial over here. But until I get it kind of down to the level I want, we're going to leave it right there. Now Bob has another name. We don't say that around here because starts too many fights on the channel for the pronunciation. So this is Bob. Bob is what you call a chucker lathe. Right now I've got a 3-jaw chuck on it, but a lot of the times I run collets. I'm up against my tool. That helped a little bit. There's another set of levers over here. This one goes for my speed, and this is forward, reverse, and brake. As you can see, this piece was kind of dirty and off, but we'll get it down there. Look how big a dial this thing has. I mean, you can get really precision measurements, because from here to here is 10,000ths of an inch. So we're going to take off about 15. And these are little clips that you can move around to mark where it is on your dial. And it's got gauges over here. Bob is a predecessor to the CNC lathes in that it's a production machine. It was made for high capacity output. Everything was designed. This was designed to change tools faster. The speeds were fast, back and forth quickly. So, you know, there's a little part over here. You can see it. This is a stop with 8 positions for these tools. I can set this up for each one of these tool positions and know exactly when to stop. So if you're making a lot of parts quickly, this is the machine. Then the CNCs come along, and poor old Bob, almost out of, I guess it is out of production. But every once in a while you come across a good one. Okay, got it in about 400 steel. We're going to go forward. That starts the spindle. I already went in about 15 thousandths. I'll get this round and measure it and see where we need to be. Let's say we needed to go down to 1.7 or 1.716. I could hog off a lot of material here, but don't want to induce vibrations and get it wobbling around in there. This is a nice slow speed. I'm not in any hurry. I want to do this one time and be done. We're getting there. Let's go on down to 30. Just take another 15. Notice how I don't have to change a lot of stuff. Once you get set up, you're great. Bob's quiet too. This was a one owner. I think it's a 1973 in that era. I've got all the paperwork. When the man bought it, kept it at his shop. He had like 15 or 20 machines running. And he was guess what you would call a production machine shop or a job shop. He had Bob sitting next to a second operation Hartigan. I mean, Bob Jr. I was doing a lot of work with him. I'm at 1.853. What did I say I needed to go to? 1.7 something. So I could take off 50 thousandths pretty easily. Let's see what it'll do at 50. So there's 30, 10, 20, 30, 40. There's 50. Now I'm going to speed up this a little bit now that I kind of got it a little bit more balanced. And what I'm going to do is I'm using the speed 1 and 2. I'm going to run it down to about 600 and I'm going to change it as it's going, okay? Got it in gear. Got it in 1, 4, okay, that's at 6, that's at 225. Now I'm going to 2, which should be 600. Okay, see how easy that was? And I'm leaving the feed alone. Go, Bob, go! I've got Bob raised up 5 inches. Makes it easier for me to reach the knob. We'd like to put a duck board down here, but it's kind of in the way. See where we are now. $1.805. Just better figure out where I need to go before I get there. I think it was 1.716. I took a picture of it before I left over at Don's place. And so 17160. And I did use both instruments to check that, and that's what they both got, within half a thou. 1716. 1716. Now I'm at 805. What is that? Hey, let me show you a trick. Alexa, What is 805 minus 176?
805 minus 176 is 629.
That ain't right. Alexa, what is 0.805 minus 0.716?
0.805 minus 0.716 is 0.089.
So really quickly, without screwing up my whole thoughts in my old timer's head, got 86 to go. Right, Alexa? So, we're going to take another 50 off of it. There's 80, there's 10, 20, 30, 40, 50. Start old Bob up forward and go. The chip isn't as breaking as nice as it was on the first pass. Now I'm going to reverse it. Do a spring pass on the way out. Bob's got built-in cooling right here. He uses oil. It's got a tank down here in the bottom, and sure is nice. One thing I like about the oil is the water doesn't evaporate out of it. Yes, I know I could go faster if I wanted to, but I don't really need to. I'm not making money on any of this stuff. Just love to rebuild old machines and use old machines. Let's face it, there's very few shops that this could make a living in today. My shop is sort of a retirement home for old machines. Me too. Now look at the finish on that. I don't know if y'all can see that. I'm going to get close. That's pretty nice. You guys are all cattywampus. Like Don been drinking here. Okay. That's warm. And one thing about metal is when metal is warm, it's hard to measure because it'll shrink on you when it gets cool. But I can get a lot closer than this. I'm going to see what it is. $17514. Alexa, .750 minus point.
750 the gain from Steve's tuning.
DJ Tom Hanks. 66 is here.
Alexa, stop. Come on, cooperate. Alexa, .750 minus .716.
0.75 minus 0.716 is 0.034.
Alexa, 0.754 minus 0.
0.754 minus 0 is 0.754.
Hell, I knew that. Alexa, 0.754 minus .716.
0.754 minus 0.716 is 0.038.
38. Got 38 inch to go. So what I'm going to do is take 30 off, and then we'll let it cool down. I'll remeasure it and we'll see where we are then. So we're at 30. Pardon the air compressor. 10, 20, 30. We'll speed it up a little bit. Maybe it'll break the chip better. There we go. Good, there we go. I can live with those. It was doing all right. And the spring pass going back. Could use the fancy dancy shield. But you can't see very well when I do that, can you guys? This isn't built into the machine to move around where you can't see them. I think Bob needs a better brake pad. Kind of takes a while to slow down and brake. And it's warm. I don't like to get that close. About 8 inches is as close as we'll get. It's a nice finish. Dead nuts on what I was looking for. All right. I could get out that one and do it, but this has been so close to it, I don't really care. And all I need is a couple thousandths. So what I'm going to do now is take a little bit off the end. So I have, this is what I measured. Now I'm going to take 1 to 2,000. I'm going to take 1/1000 off for about 1/4 of an inch, and yeah, that'll work. Let's just try it and see. Here we go. This is wrong way. That's 1/4. Tell you what I'm going to do. I'm going to run that and on up about 1/2 inch. Stop it. Go back. Then I'm going to add another 1/1000 and take it for 1/4 of an inch. I don't know if you can see there, but I can see the 2 lines on the end of that. I think it should take in put a little chamfer on the end of that so I can start it.